Hey, what's up, everybody? Welcome to lesson 8 on module 4. Today, we're really getting down to some dirty business. We're taking a look at multiplication of fractions, but looking at it through repeated addition. And so it's kind of taking a concept that we worked on before and something that you guys are pretty aware of, and it's kind of translating it over onto fractions. So we'll go over some things here. There's going to be a couple new concepts, and I think you guys will do great. So let's just begin by taking a look at something like, let's do 2 times 6, okay? And when we look at 2 times 6, yes, that is a 2. When we look at 2 times 6, we know that we can show this in a multitude of ways. I could say it's also 6 times 2, right? I could also say that that would be 2 times 3 times 2, right? And those would also equal 12. 2 times 3 would be 6 times 2 is 12. I could also show it as being repeated addition, right? I could do 2 plus 2 plus 2, right? Because I'm saying 2 groups of 6, or 6 groups of 2, 2 plus 2 plus 2, plus 2, plus 2, plus 2, right? 1, 2, 3, 4, 5, 6. And if I total those up, that would be 2, 4, 6, 8, 10, 12, or that would equal 12. And 6 times 2, well, that's 12. And 2 times 3, well, that's 6 times 2 is 12. So all of those are the same. What I want to kind of focus on today is a little bit of this right here, is this repeated addition. But I can get to that same answer just by saying, okay, well, this is saying 6 groups of 2, or 2 groups of 6, really. It could be 6 plus 6. So let's take a look at a fraction problem then, something that we're doing. Let's take a look at 2/3, and we're going to multiply that by 6. So we want 2/3 of 6. And what we've done before is we've taken a look at our whole, and we would say this is our whole, and we would split it up into thirds, right? So we want these 2 here. We would take our 6, we would divide it by 3, right? And we would get 2 on each one. And we would say 2/3 of those would be 4. Well, what we can also do here is say, well, 2/3 of 6, we could also do this way. We could say, well, that would be 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3, right? I'm saying I have 6 groups of 2/3. I have 1, 2, 3, 4, 5, 6. And what I would do then is, our answer is going to be in thirds, whatever it is. We don't change that denominator here because we're just adding them. And we would add our numerator. So I would go 2, 4, 6, 8, 10, 12, and I would get the answer of 12/3. And that is correct, and 12 divided by 3 I know is equal to 4. So 2 different ways of showing this. Now, what we can do is, instead of writing all of these out, instead of going, well, 2/3 and 2/3 and 2/3 and 2/3, I know that what I'm doing is I'm taking my 2 up here, and I had 6 groups of it, right? So I have my 2 times 6, and ultimately my answer is going to be in thirds. And so this is a much simpler way of writing out basically what I wrote out up here. I just wrote it here, but in a little bit different way. So I'm saying 2 times 6 over 3. And what we've learned before, and we did this when we were doing when we were adding and subtracting decimal, or adding and subtracting fractions, is that we can change the bottom and the top. We have to change them both, but we can change these numbers to make this maybe a little bit easier to deal with. And so what we would say is, well, do any of these share factors? Do they share factors? And I know that 6 and 3 here, they're friends. They're like buddy numbers. They do share some factors. I can count by 3s to get to both of these numbers. 3 divided by 3 would be 1. And 6 divided by 3 would be 2. And I can cross those off. And I can put these numbers in its place. I didn't change the overall value. Now, I can show you that. I didn't change the overall value. All I'm doing is renaming those. And if you think about it, we did that if you're adding something, right? If I'm adding 2/3 to 1/6, well, I would change the 2/3, wouldn't I? And whatever I do to the top, I would do to the bottom, and that would end up being 4/6, right? 4/6 plus 1/6. So we know that we can change the top and the bottom without actually affecting the overall product. So let's do this. We have our 2. 2 times 2. Well, 2 times 2 is 4, and 4 over 1 is also equal to 4. So to recap, what I did here was I started off with this 2/3 times 6, or 2/3 of 6. I drew it out in the traditional model over here with our tape diagram, something we've been used to or accustomed to doing here. And I got my 2, I split it up into thirds, and I got each one of those thirds was a 2, and two of those thirds was 4. But I also said that I could do repeated addition on this one, and that would be a concept that we're familiar with, repeated addition as multiplication. And when we added all those tops up, all those numerators up, we got 12. We got 12 thirds, which also equaled 4. And instead of writing those all the way out as 2/3 and 2/3 and 2/3 and 2/3 and 2/3 every single time, we thought that we could say, we came up with that you could do 2 times that 6. So 6 times. I would do 2 6 times, or 2 times 6 over my thirds. And what we did was we could do that, but we found out a little bit of a shortcut, that if I just change the bottom and change the top, I found a factor of 3 goes into both of those. That makes it a little bit easier. So let's try another one. Let's do 3/5 of 10. 3/5 times 10. Now once again, I could draw this out, and I would have my 10, and I would slice this up into fifths, and I would be taking 3 of those fifths, okay? But what we're going to do now is we're going to look at this as repeated addition. 3/5. And I could do this. I could say 3/5 plus 3/5 plus 3/5, and I would go on, and I would do that 10 times, and then I would add those all up. I would add the tops, 3 plus 3 plus 3 plus 3, all the way down. Well, what we can do is, to make this easier, is I can say, instead of the 3 plus 3 plus 3 plus 3 10 times, I can just go, well, 3 times 10, right? And that's going to be over 5, because we're dealing with fifths. So we're dealing with fifths, and that's something. See, this is something I can do right here. I can do this in my head, can't I? I could do 3 times 10, and 3 times 10 would be 30. And I would get 30 fifths, and 30 divided by 5, 5, 10, 15, 20, 25, 30. That would be 6. Excellent. We can also try using that shortcut that we figured out here, that 3 times 10 over 5. What I can do is I can take a look at these numbers and see if I notice anything. And what I do notice is this 5 and this 10. They share factors, and they share a factor of 5. And so what I can do is I can say, well, 5 divided by 5 is 1. I can count by 5 by 5s, and it's going to be 1 time, right? 5. Or I can do it by to 10 up here. I'm going to check that out. 5, 10. Or 10 divided by 5 is 2. And so what I'm left with is I have 3 times 2 over 1. 3 times 2 is 6. 6 over 1. And there we go. So this is it's a little easier, because it doesn't force me to deal with this right here. And as we get into some trickier solutions here, it's going to be beneficial. It's going to be easier, okay? So let's try another one. All right. Let's do 7/6, and we're going to multiply that by 24. We want 7/6 of 24. Well, this one's different, isn't it? Because we're dealing with 7/6 improper fractions, more than 1. In the ones that we've been dealing with where our product is smaller than our whole. But this one, our product is going to be bigger than our whole. All right. If you're doing this, pause the video and try solving this on your own using the skills that we have. What we're going to do is we're going to do this 24 times, right? 7/6, and we're going to do repeated addition over and over again. But I don't want to write it out 24 times. I don't want to do that. We're going to do our strategy, which is 7 24 times, right? And that's over sixths, because we're dealing with sixths. Now, 7 times 24. I could probably do that in my head if I needed to, but I don't want to. Let's try and find factors that we have here. We have some factors. We have some things that we can do. And it's 6, isn't it? 6 and 24, they're friends. They're buddies. They hang out on the weekends. And we can count by 6s to get to each one of these. I can cross my 6 off, and that's 1 time, right? 6. 6, 12, 18, 24. That would be 4 times. So now what I'm left with is my 7 times 4 over 1. And 7 times 4, I can do that. It's 21. 28. Come on, it's Friday, Mr. Abbott. 28. It's 28 over 1. And so I'm getting a product of 28. Awesome. You know, instead of doing all this business, that would have been tricky. And I could do 7 times 24, right? I could do that. 24 times 7, 28. I have 14, 15, 14, 15, 16, 168. So I would end up with 168 sixths. But then I would have to do that. I would have to divide 168 by 6. And that would go in here 2 times. That would be 12. And then I would get 4 and 48. And that would be 8. And that would be 48. See the extra steps I had to take when all I really could do is up here deal with 6 and 24? Sure made it a lot easier. Let's try another one. Let's do 7/6 of 27. Same thing. I'm just going to do 7 times 27 over 6 rather than writing out 7/6 27 times. Here I'm looking at what can I do? 3's, right? 3 goes into 6 and 3 goes into 27. 3 goes into 6 2 times. 3 goes into 27 9 times. So now I'm dealing with 7 times 9 over 2. I could do 7 times 27, and then once again I would have to divide it all out, and that's just making things not so nice. 7 times 9 is 63. 63 halves. 63 halves. Think about putting those together, and how many holes would you have? Well, let's just cut it in half. Let's split that up. Let's do 60 in half, and let's do 3 in half. Right? We would add those up. 60 in half is going to be 30. 3 in half is 1 and 1/2. So if I add those up, my answer is going to be 31 and 1/2. Now this took a little bit of extra effort because we got it down to this. We couldn't get down to something over 1, and so we had to split that up. But I can split things up in half. That wasn't too difficult, right? Okay. Let's try one more. Okay. Last one would be, let's find 2/3 of an hour equals some kind of minutes. How many minutes? Well, I've been doing 2/3 of an hour. 2/3, that would be 2/3 of 60 minutes. And then what I would do is I would do, well, 2/3 60 times. I can add those up, right? 2/3 and 2/3 and 2/3 and 2/3 and 2/3. Or I could just do 260 times, right? 2/3. I could do that, and then I would get 120 thirds. Or I can cross these off. These are factors. That's a 1. That's a 20. 3 goes into this one time. 3 goes into this time 20 times, and I have 2 times 20. And that would be 40 over 1. So my answer would be 40 minutes. So in conclusion, in summary, what we're doing is we're doing repeated addition on something. 2/3 of 6, or 2/3 times 6. Wow. That's just saying, I should say the of. I'm going to get rid of that of. 2/3 times 6. That's saying 6 2/3. And instead of adding it out, 2/3 plus 2/3 the whole way, I'm just saying, well, 2 times 6 over 3. 6 groups of 2. That's this 6 times, 2/3 6 times. And I could do that. That would be 12/3. But I can also say, well, this is a factor. These are buddies. And that's 1 and that's 2. And 2 times 2 is 4. 4 over 1 is a lot easier. So, you know, use these tricks. I hope you're successful with them. If this doesn't make sense, if you're not sure, watch it again. If you're still not sure, watch somebody else's video. And if you need to, flag me down. Ask me questions, post comments. Get me in class. Just don't find me on the weekends. That's my time. That's my time. Don't creep on me. All right. All right. I hope you guys are doing great. And thanks for watching.